Hi, everyone. Welcome to the TEAS math workshop presented to you by the ARC. So just a quick overview of the math section of the TEAS. It is going to have 36 questions and you'll have 54 minutes to answer them. So that's about an average of 1.5 minutes per question, which doesn't sound like a lot, especially when you think that 1.5 minutes includes you reading the problem, looking over the answers, and having to work everything out. So remember, that is an average. Some of them you're going to be able to get through faster than that, and some of them are going to take you a little bit longer. But you definitely want to make sure that you're pacing yourself as you go through this section. About 26 of the questions are going to be algebra and word problem based, which I know is everybody's favorite thing in the world, word problems. But the other 10 questions are going to come from measurement and data, which they'll give you charts and tables that you'll have to interpret. And you'll have to do possibly some unit conversions in that section too. So we're going to go over today just some of the basic kind of math skills that you should be comfortable using on the test, and some types of questions that you might see. So the first thing you want is you want to be able to convert between fractions, decimals, and percents fairly comfortably. So if you're converting from a fraction to a decimal, it's pretty easy. Just type the fraction into the calculator. You are going to have a built-in 4-function calculator on the test. Use the calculator. Don't do stuff by hand if you don't need to. That's what the calculator is there for you. So anything fractions that you have to turn into a decimal or a percent, type it into the calculator. To get the decimal, that's it, you're done. To get a percent, you'll just multiply it by 100. Easy peasy. A little more complicated if you're going from a decimal to a fraction. What you're going to want to do is you're going to want to put the decimal over 1 in a fraction, then move the decimal over however many places you need to on the top and the bottom to get whole numbers, and then reduce the fraction. So for example, right here, we want to convert 0.84 to a fraction. So we took 0.84 and put it over 1. And then what we did is we moved this decimal, we had to move this 2 decimal places to the right. So that means we had to do the same thing on the bottom here, which is where the 84 over 100 came from. Then we reduce that. We divide the top and the bottom by 4, and that's going to give us 21 over 25, which is our reduced fraction. So if you're going from a decimal to a percent, another easy one, all you do is multiply by 100, or just move the decimal to the right 2 places. If you're going from a percent to a decimal, you do the opposite. You divide by 100, or you move the decimal 2 places to the left. If you have to go from a percent to a fraction, just put the percent over 100 and reduce the fraction. So there you see we're going to convert 54% to a fraction. So 54% is the same thing as saying 54 out of 100. We divide the top and the bottom by 2, and we get 27 over 50. So now you might not get questions that just say convert this, or do this, but this might be something you have to do within the framework of a question. So just feel comfortable going back and forth between the decimals and the fractions and the percents. You also want to be comfortable with all of your arithmetic operations with rational numbers. So that is doing basic operations with fractions. Again, nobody likes fractions, but just remember, especially when you're adding and subtracting, you have to get a common denominator first. So don't forget that. Basic operations with decimals. So when you're adding and subtracting decimals, you got to keep your decimal points aligned when you're going down, adding or subtracting. Again, with decimals, you can just go ahead and throw them in the calculator. There's no need to stress yourself out doing it on paper if you don't have to. Fractions, unfortunately, you might have to do a little bit of handwork on that. And then super, super, super important, your order of operations. This is going to come up embedded in a lot of different questions. So whether it's please excuse my dear Aunt Sally, or it's PEMDAS, however you learned it, just remember remember. You start with your parentheses, you do everything inside the parentheses, then you move on to anything with exponents, then you multiply or divide, going from left to right, whatever you come across first. And then the last thing you're going to do is any addition or subtraction. So again, this is a thing, it's not probably going to be a question all on its own, but it might be in the framework of another question. So just, this is stuff you all know, you just got to remember it. You also might be asked to compare different quantities, say which one is larger, which one is smaller, put them in some type of order. So just kind of make sure that you remember all the symbols, got your less than, your greater than, equal to, not equal to, less than or equal to, and greater than or equal to. So just remember, refresh on those. You haven't seen them in a while. The easiest way to do these types of problems is to just draw a number line and put the values on there so you can see it. Usually the quantities are going to be, they might give you some fractions. If they give you fractions, put them into the calculator, get decimals, plot them out. Just a visual representation of this makes it a little easier for you to answer it rather than trying to kind of work through it in your head. So here's an example. Which of these numbers in the following series has the greatest value? -7, 0, -2.1, or -0.8. So if we go ahead and we draw a number line and then we plot each of those values. So you see we've got -7 down here, -2.1, -0.8, and then 0. Your greatest value is going to be the one all the way on the right here. So in this instance, our answer is C. 0 is actually the greatest value in this question. So you're also going to have to be comfortable solving equations with unknown variables. So those are your X's and your Y's, and sometimes A's or B's or M's or P's, anything like that. So your goal is to isolate the variable by itself on one side of the equation. So you always want to kind of work from the outside in. You're going to collect all of your like terms. Remember again, your order of operations. And then for these types of questions, you can always check your answer by plugging it back into the original equation. And in some instances, it's faster if you just take the answers, plug them back into the original and see which one is right. So with standardized tests, there's never a wrong way to get the right answer, if that makes sense. You don't have to do, all the steps like you learned in school or in any of your classes. Whatever is going to get you the right answer is how you want to do it, because unfortunately, you are on a time crunch. You don't have infinite time to work each problem out. So in some instances, it is faster. If you just take the answers, plug them in, then you don't even have to work anything out. You just go one at a time until you find the one that's right. But for example, if we had something like this, we had 3x plus 12 equals 5x minus 10. If we were going to work this out, the first thing we want to do is collect all of our x's on one side of the equation. So we are going to subtract 3x from both sides. And that will give us 12 equals 2x minus 10. Then we're going to collect all of our non-variables, all of our numbers on the other side. So we're going to add 10 to both sides. And then we have 22 equals 2x. We divide both sides by 2, and then we get down to x equals 11. So not too bad. Just remember your order of operations. Remember collecting like terms. Again, just refresh yourself. This might not be, you might not have seen something like this in a while. But again, I'm confident you all know how to do this. You just got to remember. So now the next chunk of time, we're going to talk about word problems. I know, nobody really likes word problems. Word problems are kind of the point of math. It is math in the real world, but something happens when you see words and numbers all together. And I think we all just kind of have that knee jerk, like, I don't know where to start. I don't know what to do. You kind of freeze, and you can't freeze when you're on a test. So if you practice and you have kind of a strategy going in, so you feel confident that you can answer these, you'll do yourself a favor. So with these, it sounds silly. Read the entire problem before you try to solve it. Read it carefully. You always want to start with, find out what the question's asking you to find. What is the quantity you're searching for? What are you solving for? And then if you know it right away, go ahead and answer it. If you read it and it comes to you and you know exactly how to do it, just do it. There's no one way that's correct to approach these problems. If you don't need to go through the whole process, don't go through the whole process. If you don't know it right away, then you're going to identify all of the information that's given to you. You're going to, make a plan, write down what's given to you. Sometimes just writing it down, it'll jog something loose and it'll come to you on how you're going to set it up and how you're eventually going to solve it. So one of the main things in solving word problems is translating the words in the problem into expressions and equations. So word problems have to be translated into math in order for you to solve them. So if you think of it kind of as a different language, it's helpful, because then you can just look for key terms. So there's going to be terms in these word problems that are going to tell you what you need to do. So addition, you're going to see sum or total, combined, added to, more than, increase, stuff like that. Subtraction, you'll see difference, subtracted from, less than, fewer, decrease, reduced by. Multiplication, a big one is of, times, product of. If you're doubling or tripling something, that's multiplication. Division is going to be out of. If you take something in half, when you're doing percents, if you're going to quarter something, those are all indicating that you're going to divide to answer the question. So here's another example. Our friend Sergio here had 12 fewer credits than 5 times what Joanna had. Which of the following expressions describes the number of Sergio's credits? So again, these make your brain hurt a little bit when you read them, because it's like, why would you say it like this? It's kind of confusing, but just look at what the problem's telling you. This is typically the first step in any kind of word problem that you're going to solve, is you're going to have to get yourself some kind of equation with an unknown quantity that you're going to solve for. So in this instance, we're looking for an expression to describe the number of Sergio's credits. So Joanna's credits are the unknown here. So they're going to be our X. And then we see Sergio had 12 fewer. So that translates to minus 12. And then we see 5 times what Johanna had. So we can say 5 times X, because X is Joanna's credits. So you put that all together, and then our answer would be D, 5X minus 12. That is 12 fewer than 5 times what Joanna had. It's okay if in the moment you can't take all these steps. You can look at the answers given and you can kind of see which ones don't make sense. Like right here, this one, 5 times 12X. There's no fewer, there's no minus. So we can already kind of take that one out. Even if you see, the 5 times is going to be a 5X. So we can take this 12X out. You can kind of, by process of elimination, start taking some of the answers out, and then kind of look at what you have left and see what makes sense. So even if on some of these problems, you can't work them all the way out, use the answers they give you to make good guesses. You always, you never want to kind of just guess blindly, because then you only have a 25% chance of getting it right. But if you can knock 2 of the answers out, and, usually there's going to be one kind of crazy answer, and you can take that out. The more answers you can take out, you can get yourself down to a 50-50 chance of getting it right. So even if you can't work it out, you have a 50% chance of getting it right. So some of the word problems that you are going to have potentially could involve percents. So always remember, when you're doing any kind of calculations with percents that you need to convert them into decimals first. So you need to divide them by 100 or move the decimal 2 places to the left before you do any kind of addition, subtraction, multiplication, division, anything like that. And then also it's important to remember percents are just the part divided by the whole. They're the piece out of the whole thing. So if you can kind of think of them in that context, it makes it a little easier to set up some of your equations. So here we have a question. At an electronics store sale, Jasmine purchased a computer tablet that was marked down 23% to $346.50. What was the original price of the tablet? So now I'm guessing a bunch of you probably took quantitative reasoning. So if you did, these kind of questions probably look a little familiar to you. And I know, just because you took a class doesn't necessarily mean that you remember how to do it, but you might see some questions like that. So we want to start by looking at what we're solving for. So we were looking for the original price of the tablet. That's our X. So think of that, that's our total. So if we know that the percents are the part divided by the total, we can do some algebra. We can find out that the total is the part divided by the percent. So we're looking for the total. We have the part. The part is the $346.50. That's the part. That's what we paid out of the original. So here's, something to keep in mind, the 23%, that's not our percent. We didn't pay 23% of the original price. It was 23% off. So we have to subtract that from 100 to give us 77%. So if you go to a store and you buy something that's, 23% marked down, you are paying 77% of the original price. So that's kind of just, something to keep in mind when you see these types of problems. So then we're going to just plug it in right here. So the total, our original price, is going to be $346.50 divided by 0.77, because remember, we take the percent and we turn it into a decimal before we do anything with it. And that's going to give us $450, which is answer A. So these two, we could look at it and we could say, hey, D seems really big. Use your intuition. If something is marked down 23% and you're paying $346, doesn't really make sense that the original price was $1,500. So you could kind of, immediately take that out. Use your intuition, you can kind of estimate, and then it's always good to make sure that your answer makes sense. I know it's kind of silly to say, but it's easy when you're in the moment and you're under the stress of the test that you just kind of work it out, you plug it in and you grab an answer, but just kind of take a second to make sure that your answer makes sense before you commit to it. So then another type of word problem that you might see, you can solve with proportions. So proportions are where you can set up two ratios in fraction form that are equal to each other. And that's when you're going to use cross multiplication to solve for the unknown quantity. So again, if you took quantitative reasoning, you did a little bit with ratios and proportions. You typically, there is a chance you're going to see a problem or two that can be solved this way. So we have Tamara here. She reads 40 pages of a novel in 52 minutes. We want to know how long it will take her to read a novel of 200 pages. So she can read 40 pages in 52 minutes. 200 pages are going to take her how long to read? So we can set up our proportion to look something like this. So we have 40 pages in 52 minutes, 200 pages in X number of minutes. So make sure you keep your quantities and your units the same. So we have pages on the top on both and minutes on the bottom, because then we're going to cross multiply. So we can take 40 times X equals 200 times 52, which gives us 40X equals 10,400. We divide both sides by 40, we get X equals 260. So at this point, you're like, boom, I answered it, 260 minutes. Then you go look at the answers and you see they're not all in minutes or in hours and minutes. So you're gonna have to take the extra step to convert those minutes into hours. So if we have 260 minutes and we want hours, we're gonna divide by 60. So that's gonna give us 4 hours and 20 minutes, which is answer D. Another type of word problem you might see will deal with rates of change. So your rate or your speed equals distance over time. So those are the kind of, if you are familiar with this triangle here, if you're solving for rate, it's going to be distance divided by time. If you're solving for distance, it's going to be speed times time. And if you're solving for time, it's going to be distance divided by the rate. So just kind of an easy way to remember how to set those types of problems up. Now, when you hit so I think they said about 10 questions are going to come from data and measurement. So you're probably going to see some kind of graphs or charts or tables. You're going to have to be able to identify them and interpret the data in them. So always read the title of the chart, see what it's presenting to you. And then you need to always make sure you read the labels when you have a graph on the horizontal and the vertical axis, because they're going to tell you what the units are, what you're looking at. And then sometimes, especially the pie charts or even bar graphs, you'll have a legend that's telling you even more. So basically with these, just make sure you're looking at all the parts. Look at what the chart or the graph is actually presenting to you. So one type of chart you might see is a bar graph. It's used for categorical data, and it lets you do quick comparisons. So for this example, we're looking at students' favorite types of nuts. So we can look at it and we can say, okay, 10 students liked peanuts the best, and only 3 students like walnuts the best. So peanuts are the most popular. So it's just a quick way to kind of categorize data. You can also use these to show changes over time. On the horizontal axis, a lot of times you'll see, years or months, and you can look at the trends of, kind of anything. Another type you might see are scatter plots. So for those of you who took statistics, this might look a little familiar to you. A scatter plot is a way to show the relationship or the possible relationship between 2 different variables. So the closer the data is, the more linear it appears, the more correlated the 2 variables are. So we can see this data right here, weight and height of children. So we have height on the x-axis here and weight on the y-axis. So we can see it's pretty, the trend is pretty close to a line. We can see as the height increases, the weight increases, which again, common sense tells us that makes sense. You do need to remember though that correlation is not causation. That's the number one thing. Any statistics class you take, that's the number one thing you probably took out of it. Correlation does not mean causation. Just because we can plot what looks like a close relationship between 2 things does not mean that one thing is necessarily causing the other. We can just show that if this one thing is increasing, typically this other thing is increasing. There could always be other factors around it. So we can't always say like, oh yeah, this causes this, but we can say there is a correlation. It shows a relationship between X and Y. So you want to remember, if your data is going up like this, it's a positive correlation. If our data was going down, it would be a negative correlation. So another kind of chart you might see is a pie chart. So it is used for categorical data, just like bar graphs were, but it's going to show you the amounts relative to each other. Instead of individual bars, we're putting it all together as pieces of a pie. So the numbers on here are either going to be percents, or it might just be numbers that when you add them up equal the total number of whatever the thing is you're looking at. So this one here it's a recommended diet. So, right, you're recommended to have 30% of your diet be fruit, 18% be vegetables, 23% be protein, that kind of breakdown. If we added all those percents up, it's going to equal 100. So you can just, by looking at that, you can say, grains is a much smaller portion of your diet than fruit is, or recommended anyway. So for example, you might see something like this. This is a pie chart showing the nurse's time per shift in hours at Sound Shore Hospital. So that, again, that's why it's really important that you read the title, because it tells us it's in hours and it's how nurses' time is broken down per shift. So the whole circle is going to be their total shift. And then each of these, patient care, prep work, paperwork, miscellaneous, is the amount of time they spend on each one of those things. So we can look at it and say, okay, obviously they spend the majority of their time on patient care, and then the rest of their time is divided up amongst the other things. So this question says, what percentage of the time do nurses spend on prep work and paperwork? So first we need to know the total number of hours in their shift. So you do that just by adding up all the numbers on the pie chart. So we take 5.2 plus 0.7 plus 0.7 plus 1.4, which gives us 8. So their shift is 8 hours. Now we need to know how much time they spend on prep work and paperwork. So you're just going to add those two categories together. So 0.7 plus 0.7 equals 1.4. So from there, we can calculate the percentage. We take the part over the total. So the part is the 1.4 divided by the total, which is 8. That gives us 0.157. That's a decimal. We want it in a percent. So we're going to multiply it by 100, and we're going to get 17.5%. So our answer is C. This is another one where you can kind of, again, if you sort of freeze up and you're not really sure how to start, you can always look at the answers, and we can look at, look at 48.5 here. 48.5 of a circle is going to be close to almost half the circle. If we look at paperwork and prep work, it's not even close to half. So obviously we know it's not 48.5. So you can kind of make, again, if you can't work them out, it's okay. Just try to make the best educated guesses you can on the ones that you can't work out. So you're giving yourself a better shot of getting the right answer. If you kind of, if you just forget how to do a problem, that's understandable. It happens to all of us. But if you can use your common sense and look at the answers, you can usually eliminate one or two and give yourself a fighting chance of getting the right one. So you might also see some questions dealing with geometry. So just remember that perimeter is the total length around a shape. So with squares and rectangles, your perimeter is 2 times your length plus 2 times the width. With circles, the perimeter is 2 pi times the radius, or pi times the diameter, whichever they're giving you. You can do it either way. Now, area is the amount of space covered by the shape. So squares and rectangles, it's just length times width. If you have a triangle, 1/2 base times height. And for circles, the area is pi r squared. Again, this is stuff that you know or you knew. You might not have used it in a while. So just make sure that, you kind of are refreshing on this stuff so that you have it if a question like this pops up. For pi, you're going to use 3.14, or you can use 22/7. It'll give you kind of the same. 3.14 is just a decimal approximation of pi, which is 22/7. So you can use either one. So for example, if you were given this figure here, and then you were asked to find the area of the figure, how would we go about doing that? It's not just a square, it's not just a circle, it's made up of 3 different shapes. So we're going to have to calculate the area of each one of these shapes individually and then add them up. So it looks kind of overwhelming, but if you just break it down piece by piece, you can tackle it. So we start with the area of the rectangle. So length times width. So we have 12 times 36, which gives us 432 centimeters squared. Then we would find the area of the left triangle. So area of the triangle, 1/2 base times height. So that's 1/2 times 16 times 12, which gives us 96. And then looking at the right triangle, we have the height here, 10. The base isn't written on here, but down here, we know this is 12 centimeters. So this is also going to be 12 centimeters. So to get the area of this one, it's going to be 1/2 times 12 times 10, which gives us 60. Then we add those three up, 432 plus 96 plus 60 gives us 588 centimeters squared, which is answer D. So they're not always going to be it's not just going to be probably a triangle or a square. It's going to be something where you're going to have to use, maybe multiple steps or different formulas, but you can always break them down. These kind of questions, you can always just break them down into their parts. You can see the two triangles, you can see the rectangle, you know what to do with those. So just take the pieces that you know what to do with and start there. Another part that might come up are unit conversions, which, you probably are already dealing with studying for the science section, because that's kind of a part in chemistry. So know how to convert units via dimensional analysis. One method, which is the method I like, a lot of people like, is the train track method, because then you can kind of keep, starting with 30 milligrams here, milligrams on the top, milligrams on the bottom, kilograms. So you can kind of keep track of all of your units canceling out to get down to the quantity that you're looking for. So if you're a little rusty on unit conversions and how to set those up, I highly recommend you do some practice problems. Look at converting, even just converting between like centimeters and meters, or milliliters and liters. You kind of need to remember, there's 100 centimeters in 1 meter, or there's 1,000 milliliters in 1 liter, all your prefixes. So those you do want to refresh yourself on if you're not, if you haven't used it in a while, you haven't looked at it in a while, you want to look at that and you want to practice some problems like that, because a couple might pop up not only in the math side, but also on the science section too. So that's a little bit of, the types of questions you might see and the types of math kind of skills that you might want to review or refresh or practice, just to make sure that, even though you knew how to do it, that it's fresh in your mind when you go sit down to take the test. So again, the test taking strategies, do the easy ones first. You don't want to waste a bunch of time on a problem early on, and then run out of time to do a couple of easy ones at the end. They're going to take a variable amount of time. Some of them are going to be, super quick, and some of them are going to involve a few more steps. So, if you hit a problem and you either look at it and you know how to do it, but it's going to take a while, or you look at it and you just sort of freeze up and you have no idea, just at that point, just make an educated guess and make note of what question that is, so that if you have extra time, you can go back to it. So try not to leave any question unanswered. Always kind of try to make a guess before you move on, but just make note of it so you can go back. So we talked about educated guesses. Every answer that you can say, oh, that's kind of nonsense, or I know it's not that one, it gives you a higher probability of guessing the right answer. So, take 30 seconds to read the answers and use your common sense to say, okay, that doesn't make sense, or that answer doesn't look like the other ones. It's probably not that one, to give yourself less answers to choose from. Don't be a hero, use a calculator. It's what it's there for. So I think sometimes in times of stress, we feel like we have to write it all down, or we have to do things in our head. don't do things in your head if you don't have to. Don't convert a fraction to a decimal using long division. I know you know how to do it, but it's time that you don't have. It's time you could be spending on a different step on a different problem. So use your calculator. It is exactly what it's there for. So when you hit a problem, the word problems, just write stuff down, draw pictures if you need to. However works for you to kind of jog it free, especially if you look at something and you're not immediately sure what to do. Sometimes just writing something down will jog something free, or will, you'll write it down and it'll come back to you how to answer it. So just don't be afraid to write stuff down and work backwards if you get stuck. Said it earlier, there is no one right way to get to the correct answer. So there is absolutely nothing wrong with you not working a problem out and just taking the answers and plugging them in and seeing which one is right. You're potentially saving yourself a lot of time there, and you're getting the right answer. This is not a test. It's not a test that you take in class where if you got the answer right, but you didn't do the process right, you're going to get points off. This is just the answer. The only thing that matters is you get the right answer. And finally, make sure your answers make sense. I think we talked about that too, especially if you're making an educated guess. Make sure that it's not, there's typically a lot of times there's going to be one answer that's just, if you take a second, just really does not make any sense, and you can obviously rule it out pretty quick. So, and unfortunately, a lot of times they're going to put common wrong answers as a choice. So if you make a common mistake, so just kind of think, you worked it out, just think, take a second and say, does this answer make sense for the question that's being asked? And finally, most importantly, don't panic. I know a lot of people have math anxiety. It's very real. It is, for whatever reason, if math is not your thing, or, don't let that freeze you up. I will say the math section from our time here in the ARC, students coming in before they take the test, they usually stress about the math section a lot. And then a lot of students come in after they've taken it and they say, oh, hey, the math wasn't that bad. The science is really hard, or the reading comprehension is really hard. If you've taken quantitative reasoning or statistics, you have a good background for a lot of these, these skills that you're going to need. It's not a bad idea. You kind of look back through your notes if you have them. If not, just look at the practice tests. I can't stress enough practice tests just to give you confidence. And a lot of times, even if math really freaks you out, try just doing, 2 or 3 practice problems every day. Sort of desensitize yourself to it. Break it into little chunks. Don't sit there and try to spend 2 hours beating your head against a problem. That's not going to help. But if you can do 2 or 3 practice problems every day or every other day, and just kind of get used to the process and sitting down and doing it, that's going to be a big help. If you read a question, if the first question that pops up, your brain just sort of freezes, don't let it freeze you for the rest of it. Make an educated guess, move on. Find a question that you do know how to do, that you do feel confident in. The more stuff that you feel like you're getting right, the more confident you're going to be, the better you're going to do on the section. So, we do understand, I do understand that math is pretty stressful, and, standardized tests, it is timed. You have all of these things kind of going on, but try to set yourself up the best way you can for success. So that's practice problems. That's if any of the things that we talked about here today, you feel like you're a little rusty on, or maybe you don't remember as well, you're more than welcome to come into the ARC and work with one of our math tutors. We have tutors who have taken the TEAS. They can talk to you about it, about strategies. They can maybe make you feel better that it's probably not going to be as hard as you're making it out to be. They can talk you through it. You can do practice problems with them. They can give you strategies they use, stuff like that. So Please feel free to reach out to us if you have any questions. We have more resources posted on our LibGuide. The link to that is on the tutoring website. So thanks for coming today. I hope this was helpful to you. If you want to know more, like I said, email or click into the virtual ARC Monday through Thursday between 10 and 6 are our drop-in hours, or you can always request an after-hours appointment if you want to meet with somebody in the evenings or the weekends. So thanks for coming, everybody. I hope you all do well. I wish you all luck, and I hope that you know that, you can do this. So thanks again.